Okay, so today we are going to continue talking about coterminals, but we're going to be finding arc length and the angle formed. So two things. We've talked about some of it already. So let's review. The first thing is changing from degrees to radians. So I'm going to give you 3 examples of each in radians to degrees, and I want you to, as quickly as you can, do them. So number 1, degrees to radians. Let's try 45 degrees. Let's try 170 degrees. And let's try 310 degrees. For radians to degrees, let's try 13 pi over 18. Let's try 11 pi over 4. And let's try 5 pi over 6. Alright? I'm going to actually, as you were doing that, start writing the answers up so that you can check them as we go. That way it's not boring for anyone who happens to watch this. Alright, so I'll give you a few minutes and start.
When it's like that, do you put the pi in the numerator? When it comes out like this? You put pi.
Yep. Wrap up the first 3 and check your answers. Any questions how to get them? Okay. Then the next ones. And again, check your answers, but then we're going to take a special look at number 5. All right, any questions how to get those answers? Now, one extra step for number 5 that is not up here. This is not between 0 and 360, so I have to subtract out one complete turn of the circle to get a 35-degree angle. Okay, so the 495 is correct. These are coterminal, but we do want, in degrees, numbers between 0 and 360. So we want to make sure that we get it there. So if we get a number that's over 360, we do need to subtract out that extra thing. And just like if we get a negative, so if I had negative 40, I would need to add my 360 to it to get the coterminal of 320. Okay, so we do want all of our angles between 0 and 360, and we do want to make sure we do that. Okay, I want to make sure that I hit the new stuff for today, which is arc length. So let's do that next. Alright, there are a few different ways to do arc length. I'm going to talk about the easiest way, which is using radians. So if you're given something that's in degrees, you need to change it to radians to find arc length in the easiest way. Remember, a radian is defined as the length of arc that is equal to the radius of a circle. So if I have a circle here, and let's say I draw a radius of 5, and a radius of 5 right here, okay, and then I'm going to give you, let's just say that this angle right here is 60 degrees. We'll make it 60 degrees. We are going to use the following arc length formula. Arc length equals theta times r. So that L is representing arc length. This theta is representing the angle in radians. It must be in radians. And r is the radius. It is a very simple formula. Oh, I'm writing radians there. I meant radius. Very simple formula. Now this 60 is not in radians, so I'm going to have to change it. So I do 60 degrees times pi over 180. I can cancel. That becomes a 3, that a 1. And my angle now, theta, is pi over 3 in radians. Notice there's no degree symbol there. Now all I have to do is go to my arc length formula. Arc length is pi over 3 times my radius, which is 5. Arc length, now the denominator here is a 1, so 5 pi over 3, that's the exact answer. It's possible that I might want an estimated answer, so I would go ahead and put in pi, and you can use your calculator's pi button and get 5.236 rounded to the nearest thousandth as the arc length. So top answer right there is exact. This second answer there is an estimate.
So how did you get the estimate?
The what?
Multiply it by 3.14?
Yeah.
Okay.
Okay. I used my pi button though, so that's why I have some extra decimal places there. You can use your pi button on your calculator. It gives you more than 3.14. Okay, let's do another example. This time I'll give it to you in radians. Alright, let's find the arc length of, now I'm going to darken this arc. I want this arc right here. And I'm going to say that right in here is pi over 4. Now that's not in degrees because I don't have a degree symbol there. That's definitely radians. But I want the length of this arc. Let's get a radius of 8. Now I need, in order to find that arc length, I need this angle right here. But I don't have it. So the following fact is going to be very important. So you'll want to memorize this somehow. Let's go through this like we did yesterday. How many degrees right here? If I'm right here, 0 degrees. And if I'm right here, 90 degrees. And it's an additional 90 each time, right? 180, 270 degrees. Now I'm going around. And then I'd get to 360, right? Right here. Now we would just count a 360 degree angle as a 0 degree angle. Those are coterminal. They're the same. Now let's do it in radians. In radians, this is 0. In radians, this is pi over 2. In radians, this is pi. If you were to do our changing, this is what you get. This one I forget. I think it's 3 pi over 2. And the last one is 2 pi. So 360 degrees equals 2 pi in radians. So a whole circle is 2 pi. So if I want this piece right here, I'm going to have to do 2 pi minus pi over 4. In order to do the subtraction, I need a common denominator. It'll be a 4. So I rename this fraction. And now I can do my subtraction. 7 pi over 4. Notice I don't subtract my denominators, right? So this is my angle. It was already given to me in radians, so I did not have to do any extra work. Now I use my formula. My formula is right here.
Can you slow down a little bit?
I'm going to do lots of examples. So I have my radians. How did I get that? 2 pi is a whole circle. I subtracted this little piece because I don't want this arc. I want this one. I got 7 pi over 4. We know how to subtract fractions, so I'm not going to spend time on that again. Times radius. So theta is 7 pi over 4. My radius is 8. And now I just do my multiplication. What's my denominator on my 8? 1. Top times top, bottom times bottom. I can cross cancel, so I will. I get 14 pi. Done. Alright, that's my exact answer. And if I use my pi button to get a estimate, I get about, so that's my approximate symbol, 43.983.
Is it going to ask us for
or 2. Huh? I'm doing both, so you can do either one. It depends. Alright, I will do one more example, then we are going to call this topic done. It's pretty easy. Sometimes they'll give you the arc length. Maybe we'll do one of those, and you'll need to find the angle. They don't always give you a picture, but I'll go ahead and give you a picture. Let's say this is 50 degrees in here. What do I need to do first in order to find my arc length? And we'll say this is 10. The radius is 10. So I want this arc length. How do I do it?
Have to change the degree to radians.
Yep, change the degrees to radians. So I'm going to take my 50 degrees and I'm going to change it to radians. Alright, it looks like I'm going to get 5 pi over 18 after cross canceling. Okay, divide by 10. Alright, so this is my angle. My formula is theta times radius. It is very simple formula. All I put in here is my angle. See, goes in. 5 pi over 18 times my radius is 10. I can cross cancel, so I will. Divide that by 2 and that by 2. And I get arc length is 25 pi over 9. That's the exact answer. And then I can go ahead and put in that into my calculator and get an estimate. And that is the estimate. That's how long this is in whatever units. If this is centimeters, then this is centimeters over here. Alright, I'm just going to do one example of the following thing.
Wait, can you show me how to get the estimate on the calculator? Because when I try to do the pi button, it gives me the same answer.
You press your fraction to decimal key.
Gotcha.
Okay. Let's say we want to find the angle if the arc length is 20 pi and the radius is 2. Well, here's my formula. I plug in what I know. I am told that the arc length is 20 pi, so I put in 20 pi. I don't even have to draw it out. I'm finding theta, so here's theta. Radius is 2, so times 2. And now this is a basic equation. I go ahead and divide both sides by 2, and I get theta equals 10 pi. So this arc length actually has gone multiple times around the circle. Okay, so it's a really long, maybe the circle's turning or something like that. So this, I don't know, depending upon your perspective, might not make sense. All right, let's do another one. Let's find the radius if, thank you, find the radius if the arc length is 10 pi and the angle is, let's say, pi. I could put any numbers there. It's going to be, actually, let's make it harder. Let's say the angle is pi over 2. All right, so I have my formula. I put in 10 pi for my arc length, pi times radius, so I mean my angle times my radius, so pi over 2 times radius. Now I see fractions here. I should clear my fractions, so I multiply both sides by what number? 2. So I get 20 pi equals pi r. I divide by pi, and I get 20 is my radius. Okay? So you can use your formula to work backwards to any point. Alright, so review from yesterday. This is the complicated thing. So I want to make sure that you're good at it. We are going to find the angle formed by a terminal ray and just review that part. So we do need to remember our sine of an angle, our cosine of an angle, and our tangent of an angle. And let's say this is opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. For this, usually, and probably always, we'll be using tangent. So let's say I have a point. Let's say I have the point 3, 2. That's right here, 3, 2. And I have a ray that comes up and goes through that. Okay? Now, I want to know, well, what is this angle right here? What is that thing? You with me? So I'm going to complete my triangle. See, I complete my triangle. How long is this piece right here? 3. And how long's this? 2. And my angle is right here. So look, I have opposite over adjacent. So that's tangent of my angle equals opposite over adjacent, 2 over 3. Now, from yesterday, anytime we want to find an angle, if I want the angle and I don't have it, inverse. We're going to use inverses. So I'm going to inverse both sides. So the inverse of a tangent, inverse tangent of tangent, is going to give me the angle. I'm going to inverse tangent this 2 over 3. So what is the inverse tangent of 2 over 3? I'm just putting it in 33.7 in degrees. Make sure that you're in the right mode, because during this chapter and the next chapter you'll be switching between radians and degrees quite often. I typically just leave my calculator in degree mode, and then I know that if I need radians, I'm going to have to convert. I'm going to do 2 more examples of this, and then we are going to go to our book pages. Any questions on how I set that up? Alright, let's do another example. Let's say that my angle now is down here.
Wait, what was the answer to that one?
33.7.
Okay, so this point is 2, -5. So this is my terminal ray. Okay, now I am actually looking for, please look up and pay attention to this, I'm looking for this angle right here. I always want the counterclockwise angle. But there's no way I'm going to create a triangle that includes that angle, right? So I'm going to have to do a reference angle. That's going to be, I'm going to draw this triangle, and I'm going to find this reference angle right in here. I typically like to call my reference angles alphas and the actual angles thetas. So my reference angle is in here, and I'm going to do it the same way as I did the other one. Now, how long is this side right here? And how long is this side right here? 5. Okay? So I'm going to do tangent, because again I have opposite over adjacent, 5 over 2. And then I want this angle, so I'm going to do the inverse tangent of 5 over 2. Here it says it's 68.2. We'll go with that. Okay? Now that's this angle in here. Now I'm going to have to use my head a little bit. Make sure you're looking. I want this angle. I have this one. It's 68.2. But I want this one. Well, how many degrees are in this whole circle right here? So I'm going to take 360 and I'm going to have to do an extra step and subtract that 68.2. And when I do that, yep, 291.8. Okay?
How do you know if you're having to go all the way around?
Huh? Say that question again.
How do you know if you're going to have to go all the way around?
Maybe this next example will answer your question. The short answer is always. Sorry. That'll be online in a minute. Like, I'm always going to start like on this, and I'm going to start going this way. So if my angle's right here, that's where I'm going.
Oh.
Okay. So, but maybe my angle's over here.
You just go.
So then I'm looking for this one. But now I'm not going to use 360 because I haven't gone all the way around.
Would you just 180?
I would use 180.
If it was in
Yep.
this one over here, would you just use 270?
So let's say for the sake of argument, we did the inverse tangent thing, and we got this thing in here. Let's say we got 20 degrees. But I don't want that thing. I want this thing. I do 180 minus my 20 and get 160. And that is my answer.
So on the last one, the answer was 291.
Yes. Yes, the answer for the last one was that. All right, and let's say that I'm now here. And let's say when I do all the math, all that inverse stuff, let's say I get this is 70 degrees. Well, now I've done 180, but now I've gone an additional 70. So then I do 180 plus 70. Okay? And we would get 250. Now, if you are someone who, like, I think of it like that, but you can memorize something if you want. If I'm in quadrant 2, I'm going to do 180 minus my reference angle. If I'm in quadrant 3, I'm going to do 180 plus my reference angle. And if I'm in quadrant 4, I'm going to do 360 minus my reference angle. Notice it's different depending upon which quadrant you're in. I like to just draw it and think about it, but if you're one of those who needs to memorize, you would have to memorize these 3 formulas, and they change for each quadrant. Quadrant 1 is alpha. It's just whatever you get. Okay? So that's finding the angle formed by a terminal ray. So that gets you ready for everything that you're going to do in your book today. And we are done with life.
Kill us now.